In question 8, we have a diagram which shows part of the curve y is equals to 6 upon x. The points 1 upon 6 and 3 comma 1 comma 6 and 3 comma 2 lie on the curve. The shaded region is bounded by the curve and the lines y is equals to 2 and x equals to 1. We have to find the volume generated when the shaded region is rotated about the y-axis. Now, whenever it is rotated about the y-axis, it means that we have to make sure that our equation is in terms of x. So the curve equation will be written as x equals to 6 upon y. Now, first we'll find the volume which is lying under the curve, which will give us this total volume, and then we'll subtract the volume which is lying under the line. So for volume, we use the formula pi times x squared dx. Now the limits will be 6 and 2 as the coordinates are given. So this is 6 and this is 2. So we'll write pi times 6 upon y whole squared dy, and the limits are 6 and 2. And we'll subtract it from the volume of the line, which will be 1. The equation is x equals to 1 as it is a perpendicular line at the point x equals to 1. So we'll write 1 squared dx and the upper limit and lower limit is 6 and 2. So integrating 6 upon y squared, this will become 36 y to the power minus 2. Integrating this, we'll increase the power by 1 and divide it by the new power, which is minus 1. So this will become minus 36 y to the power minus 1, which can be written as minus 36 upon y. Now we'll substitute the upper and lower limits, which are 6 and 2. We can just add pi to the final answer. Minus, we know that the integral of 1 is x. So this is x and the limits are again 6 and 2. So putting 6 in place of x, we get 6, minus putting 2 in place of x, we get 6 minus 2. Substituting 6 into the equation, we get minus 36 upon 6, which is minus 6. Substituting 2 into the equation, we get minus 36 upon 2, which is minus 18, minus 4. So minus 6 plus 18 is 12. 12 minus 4 is 8. So the total volume would be 8 pi. Now in part B, we have a tangent to the curve at a point x and it is parallel to the line y plus 2x equals to 0. So the line has equation y is equals to 2x, which means that the gradient of this line is minus 2. So the tangent to the curve at point x will also have a gradient of minus 2. We know that the equation of the curve is y is equals to 6 upon x, which can be written as y is equals to 6x to the power minus 1. Finding the dy dx of this equation, we get, so we multiply the minus 1 by 6, we get minus 6. Decreasing the power by 1, we get 6x to the power minus 2, or minus 6 upon x squared. We know that the gradient is minus 2. So this will become minus 2 is equals to minus 6 upon x squared. So x squared will be equals to 3, or x will be equals to square root of 3. Now we have to show that the line, that x lies on the line y is equals to 2x. So the coordinates of the tangent to the curve, we know that the x coordinate is square root of 3. So the y coordinate at the tangent will be y is equals to 6 upon x, and the value of x is root 3. Now rationalizing the function, we multiply and divide by square root of 3 to get rid of the square root sign in the denominator. We get 6 square root of 3, and root 3 times root 3 will become 3. So we know that the coordinates of the tangent to the curve are root 3 comma 2 root 3, and these points must satisfy the equation y is equals to 2x. So we'll use y is equals to 2 times the coordinate of x is root 3. So the value of y is also 2 root 3. So basically this shows that x lies on the line y is equals to 2x.